Hi and welcome to my Playhouse, and today I purchased a new oscilloscope. Well, new and new. I never had an oscilloscope before. I'm even educated an electronic engineer. That's the rough translation of that. And well, I worked with oscilloscopes when I was taking my education, and I haven't really been in the field since then. Then a few months back I needed one for the little desulfator project, and I borrowed my cousin's oscilloscope, and well, I found out that I needed one. So I purchased one, and these are really cheap nowadays. When I was doing my education, this would cost way more. But now these are really affordable because the Chinese has entered the market, and well, an oscilloscope like this, you can actually purchase that on Amazon for just over $300. So let's open this up and see what this is. Oh, this is the Hantek, and it's the 52. Where do they it's the DSO5202P. So that's what this is. It's a cheaper oscilloscope. It looks very cool though, but it's a cheaper one. It's made in China, and it's a 200 megahertz oscilloscope. Here it is. It looks pretty cool. I hope it looks nearly as cool when we get it out of there. It's not a brand new model. I saw on the internet that this has been on the market since 2016. So it has a few years on the back. So probably all the kinks has been worked out of it. Let's see it that way. And I haven't had this open. I've been waiting for you guys. So first look. There we are. Comes with a power cable, even a Danish power cable, or European. I'm not sure. Yeah, this would work in Germany as well, I'm sure. Then we have the test probes. Awesome. One test probe there. Let's see, another test probe. Cool. We'll have a better look at those. We have some manual and a CD. There is apparently some software on there. Cool. I think that's about it. We have then the scope itself and an empty box. So the empty box goes out of the way, and we'll take this foamy thing and move that out of the way as well. I got one with a high frequency of 200 megahertz and a big screen. I could probably have gotten one and gotten away with one with a lot less frequency, but I remember when I was educated, I was doing a transmitter, and that transmitter was operating at 154 megahertz, and the school where I took my education, they only had a few scopes that was able to handle that frequency, and I needed that for my project, so I had to wait around for other people to finish their stuff so I could borrow the scope for a few hours. And yeah, I just happened to be reminded of that when I was looking at scopes. So yeah, it looks like a transistor radio. I should really do, maybe it could play radio, that would be fun. Funny thing, the front has one USB connector, and the picture on the box had two. Yeah, there's two USB connectors on the box and one USB connector in real life. That's kind of weird. Other than that, I think it looks pretty much like, let's see if anything else is missing. Let's see, we have buttons, we have more buttons, we have two of those. Yeah, it has two channels, channel 1 and channel 2. You can get these with 4 channels. It's not as if it costs a lot more, but well, I barely need one channel, and it having 2 channels, well, okay, so it's fine. But I don't see anything else not being the same as on the picture. It does sound a bit plasticky. It has a USB connector on the back as well, so maybe one of them moved back here, I don't know. It will handle from 45 to 440 Hertz, 100 to 240 volts, and it uses approximately 30 watts. There is not a lot of stuff here. This is gonna be, well, I can actually see inside. Everything is nice and shielded in there. Yeah, you can kind of see here, there is the plastic, but right beneath that is actually metal. So they have shielded the device, but it's just plastic on the outside. Might as well use the cable that comes with it. So let's take that out of the bag. And there's a little tiny heating. And over here I have a power meter, so we could just see how much power it uses. Really put myself on a nice spot on the floor, but I forgot to turn on power. There, we have power on it. So let's connect this on the back somewhere over there. I should be able to plug that in and nothing should happen, because there is also an on-off switch, but let's just make sure it's still on 0.00. It's using 0 amps. Okay. So let's try and power this on. Should we remove the protective plastic? I think we should. There we are. Yeah, we want the maximum experience here. And power. Okay, it didn't stay in. There. Okay, I had to press harder than first. Hantek QR code. Your testing solution. And it's on. That was rather quick. I must admit, I expected it to take longer to boot or something. So I guess that's cool. I haven't messed with a scope in forever. I used my cousin's scope, but I just used the auto set. Yeah, that kind of worked okay for me. Let's see these probes that it comes with. Hantek probes. You need those. How do one get in there? Okay. It opens, and then there's a probe, and there are some accessories. There's kind of some color things to mark if it's channel 1 or channel 2. It has kind of yellow things or blue things, and then it has green things, and I don't know where the green things comes into the picture, but it has them. And then it has a little adjustment screwdriver for probably calibrating that thing. There is probably a little screw in there, so calibration screwdriver, nice. And then there is the probe itself. People use much money on probes. They can be really expensive. I am not a professional at this, so I'm probably just gonna be using the probe that comes with it. It's kind of, you can poke things, and you can take this and you can attach it to stuff, and that's the positive and the negative or whatever. So that's one of them. And the probe comes with a manual. Assembly, yeah, there's not much in it, but yeah, the probe is able to do 1 times or 10 times, being that if the probe is measuring 10 volts, well, over here you will get 10 volts up in whatever division you're at, but if you're at X10 you'll only get 1 volt, and then you have to remember that you have to multiply that by 10, and that is, as far as I remember, it's to protect the scope and also to be able to get better measurements. So yeah, let's see if the other one, oh, that looks just like it, so I don't think we need to take that out of the wrapping just yet. So me just using this a little bit once in a while, see that it has the date right, but it has the time wrong. So I would have to go and figure that out at some point. It uses the whole screen. That is pretty cool. and then you can press menu and it shrinks this part a little bit, and we could x1 or 1x, 10x, 100x or 1000x. I'm not sure if that's on top of what the probe is really doing, so we should try that. Okay, I picked up a 12-volt battery in the basement, and I put the probe on that. I even exchanged the colors, so you can kind of see now there's two red ones in here. They were on there. I actually liked the red ones, they looked good. I set the probe to x1, and also inside here it's set to x1, and it's seeing about 13 volts right now, and the variation that it's measuring is about 400 up to 800 millivolts. Go in here and we can see if we go in here and we set x8 to x10, now it thinks it's seeing 130 volts. So the x thing in here is just that we can set this to the same thing as the probe, and the meter will do the multiplying for us. So if we set this to x10 over here, there, and auto set, and it kind of sees 13.2 volts now. Apparently it's not as precise. I did measure this battery just before I got up here, and it is just over 13 volts, and I don't think it's 13.2. We could set this back to x1 and then try and set this to x1 there. Alt. I'm just pressing around stuff. Yeah, it sees 13 volts here. It's set to 5 volts per division. That's when I press the automatic. It tries to make it look good for me, so very nice of it. We can set that, see 5 volts. We can set that to 10 volts, meaning that every division here, each square virtually, is 10 volts, so it's just above the first square thingies, the line. It has gotten less precise here. On the scope, there's a test pin over here where we can connect this one to the top one and the ground to the ground, I guess. And we get these test squares, and we can just auto that, and it will show us some nice squares here. We could zoom in on those probably there, and we can zoom in. We can see just one square there, or we can see the rise of it, just that going up part, so we can see how that does, and the going down part there. If we want to check that out, we can remove this. We get a better picture of exactly what's going on. It sees 5.28 volts here, peak to peak, with the noise, which there shouldn't really be that much noise. And the frequency, it measures it to 1 kilohertz with a lot of zeros, so that's good. So now that it's actually doing something, we can measure the wattage here, and it uses 15.9 watts, so just beneath 16 watts. So I've hooked up the battery again, and it sees 13 volts, and the battery is right now down on the floor. And I got this oscilloscope because I was messing with these desulfators, and so I think that we should just try and connect the desulfator and see what happens if it's measurable. So when we go up now, we can see that the desulfator is making a lot of noise, and that's what the desulfator is meant to do. It measures the frequency here, and it's peak to peak. It's only 2-3 volts, which is less than expected. I think it has some bigger peaks in between, and it triggers on different stuff all the time. So let's get out of this auto set. No. Okay, that's the noise we're seeing, and then once in a while we get a spike. That's interesting. That's what I really wanted to see on the scope. See if I can figure this out. When I touch it, it does weird stuff. I was actually really impressed with the startup speed of this. So I've turned it off right now. It's connected to the battery and the desulfator. And let's do a little test of how quick it actually is. 1, 2, 3, 4. 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7, 8, 9, 10, 11 some seconds, and it's up and running. I might be used to really old laboratory oscilloscopes with old tubes that had to warm up and stuff, but yeah, this is really impressive. 11 seconds and you're good to go. Oh, I found this big menu with a lot of numbers on it. It has another menu here. I'm messing around with these menus. There's really not much of a manual here, so let's just go through the stuff. There's a certificate where some Chinese person has placed 2 stamps of some kind, so yeah, thank you. Then there's a little bit of a mini CD. Well, has the software for connecting this to a computer. Yeah, I need to find a computer with a CD-ROM drive, or maybe I could find the software online. Then there is the warranty card. Yep, don't think we're gonna need that much. Then there is this note here which tells me what was in the package, and I went through this and I realized the USB cable. I didn't see that anywhere, so I was actually cleaning up the box, and yep, that was a USB cable. So yeah, we missed that when we unboxed it. I don't know what it was attached to, but well, it came out now. So finding out how to use this when you haven't been using a scope for 25 years, it kind of had a steep learning curve to it. Yeah, this measurement thing, you can kind of pick what you want to see. Like right now we are seeing the frequency, the duty cycle, means, what voltage this is, peak to peak, minimum, maximum, pulse widths. But if we want to see something else and have it calculate something else, there's rise time. You can see the little arrow there. I'm moving that up and down. Yeah, and it moves opposite of what you would expect. So that's a little bit odd, but let's change the pulse width, and there's a little modifier down here. So press F6 and you get a long list of stuff that you can pick from, different stuff that it can calculate for you, most of which I have no idea what is. Period, mean, there. Let's try and get that. So we got that in there. So yeah, cool. I also found that this little screwdriver is actually not for that thing. It's actually to mess with the probe. If this is not square, you can adjust a little screw in there and make it square. Let's see if we can mess that up. It's pretty good as it is. Right now it doesn't really care what I'm doing, so that sucks. Okay, so this is all good. 1.5 million years ago, when I did my education in electronics, we did this little box here. It was part of what we did. We built this. I haven't had an oscilloscope ever, so I haven't really used it. I remember that we built this, but we had to actually buy it from the school because it was part of what we were doing. But yeah, they thought of how to get a little bit of money. Actually, it was a really good project because we built the case for it, and we built the electronics for it inside, and we have to build all of that and all of the components, and we learned to solder and all that stuff. I just had it down in the basement and checked if there was any power on it, and for some reason, even though I haven't had this operating in forever, there was still 9 volts on that battery, I do believe that I have replaced the battery at some point. Well, it's a tone generator. It should be able to do from 6 to... oh, it says it here. Tone generator. Oh, yeah, we didn't make this. The school had this piece of plastic that we could put on top of our box that we made. But tone generator from 6 to 60 kilohertz. So it's not gonna be able to go anywhere near where the scope goes, but we should be able to see something. I don't have those fancy things to put on here, but I have some fancy things to put on over here. So we can just put that's banana connectors, I think they might be called. So let's put those in. And then let's try and see if we can have our probe connect to that. Minus, that's easy. Plus might become a bit harder. Can we do that? Can it just go inside? Yeah, okay. I have somewhat of an issue to how to connect that. Will it do it? Yeah, it's on there. So let's try and turn this on. And it did something. Not a whole lot, but it did do something. So this is a switch X1, X10, X100, X1000. So right now it's at 1 hertz or X1. Let's switch it all the way down. This thing, I forget what that is. Is that duty cycle or something? Let's try auto. See if it will find our oscilloscope curve. Yeah, something is moving. So if we go up, will you be able to see that? Yes, it sees that something is happening. Let's try auto that. 10 volt, 2 volt. Okay, so we get the frequency over here. I can adjust that down, I guess. Yeah, so now the frequency is, let's get it to 10 hertz. Can we do that? Yeah, we can. There, 10 point something hertz. If we will then switch it up one, we should get about 100 hertz. Oh, this is old. So what did you do over here? No, you're not. Oh, that's ugly. Now it says 2.5 kilohertz. That's a bit more than I was aiming for. X1, I think. X10. There. Let's turn this all the way down. So that's about 2 kilohertz. Wonder if that battery is really not doing too well in there. Let's see the maximum frequency. There. And all the way up. That's only about 42 kilohertz. Or is this? That just turns the signal up, down. So we get maximum signal there. So that might be dampening. Apparently this does not go up to 60 kilohertz, but only up to 41 kilohertz. When you adjust it, you get all kind of crap. I hope you can see that I'm just messing around. I have no idea what I'm really doing. So there is our 41 kilohertz sinus wave. Some of the real benefits of this scope is really that it's very quiet. It has a fan, but it doesn't make much noise at all. It's just a quiet-ish, and it boots up really quickly. So if you need to measure something and see something on it, well, you don't have to wait a long time. You just have to turn it on, and as when you're mingling with these probes to measure whatever, well, it will be way done before you're ever done putting this on what you want to test. And remember to turn this off. The battery might last another 15 years. Yeah, I got myself a scope. I'm not gonna be using it that much, but I've always wanted a scope. And the fact that it's not gonna take up much space on my workbench in the basement is also a really nice feature. I would have liked it flat, like a computer monitor that you could just mount on the wall. That would have been so cool, like a good 15-inch screen, and then just some connections for the probe and the buttons and stuff. I would have loved that. I do know that that is available, that you can get like computer scopes where you just connect it to a computer and you have this tiny little box where you put these leads in and you have a screen. People tell me they're not that great, so I got this. One of the things where this scope doesn't perform that well is that it's only a 1 giga sample per second scope, which means that if you're measuring 200 megahertz for each sine wave, it only have 5 points to put in, which is not much when you're doing this and have to mark out. The more points you have, the better. And at 200 megahertz, that's pretty poor. And especially if you use both of the probes or channels, it will divide that 1 giga samples onto those 2 channels, so you have 500 mega samples per second on each channel, which is, if we're measuring down here at 41 kilohertz, it's not a problem whatsoever. I could do it a lot less, but at those very high frequencies, it's a bit limiting. I'm gonna test the computer stuff at some other point. I'm not sure that I'm ever gonna be using that. Might have a really smart couple of cousins that will come and irritate me with all the features that I need to learn about this and how I'm doing everything wrong, which you can also just point out in the comments below. It's fine. So thank you very much for watching my videos. Do subscribe to my channel so that you can see me again using this scope at some point. Have a nice day. Bye bye.